So, I'm from Syneto, and my colleagues here from Erastor already introduced me in one way or another, because what we've been doing is building software to run storage appliances. And what I'm going to show you today is a little bit of where we come from as a company, and what we've been doing with ZFS for building storage appliances. So today is going to be me as the CTO of Syneto, and my colleague Vadim, who will later have a talk on a technical talk on how we build and deploy our software. So first of all, I'm going to show you a little bit about how we become to work with ZFS. The company I work for, I'm on the company starting from 2002, and at the beginning we were building an appliance, which was a network appliance. So what we had as experience was to build software for a device which needed to be easily operated, because at the time it was quite hard to use command line interfaces and so on. And this was our first venture, and we acquired a lot of experience in building a system based on Linux at that time. Then we went on and we developed a lot of stuff based on this unified threat management solution, until we saw that the sales and the market was becoming commodity for the UTM, so we decided to find some new venture. Where should we go next? And we got this idea of going into the storage market, because we saw that that's a big opportunity, because all of the storage appliances that we could find were either extremely expensive or extremely hard to use, or not intuitive at all. And what we gained as experience during the days of the unified threat management was how to build software which is really easy to use, and you don't require so much training and expertise to run your systems on. So at first we decided to take the right way in choosing the right operating system. So we looked at various options. So we had, at the time in 2009, Open Solaris was already there, and that was one of the options. But we also evaluated Linux, where we had a lot of experience before with our previous operating system. And then, of course, we also looked very hard at FreeBSD as an option to build our operating system to run on. And at the time, FreeBSD had already the ZFS port, but it wasn't quite as mature. With Linux, there was this problem of incompatibilities between GPL and CDDL from Solaris. And that meant that it's not going to be included into the Linux mainline kernel. So that's something that it's even today. But I think that this issue has been resolved in some ways, even though it won't be there. So, and then there was Illumos. And while I was evaluating, I immediately fall in love with Illumos, because it wasn't just ZFS, which is an incredible file system. But Illumos also had a lot of other things that really attracted us, like dtrace, and then they've got the post-mortem analysis with MDB, which is very important if you really need to support systems which are based on that. And our intention was to deliver a system which is very supportable, which we can help our customers understand what's going on with their systems. So that's why we chose Illumos. And we started from there. We chose Illumos. We chose to base our system on the Open Solaris at the time, and it's still based on that. And then we started a little bit to grow the system and add something more. And some of the highlights have been the VMware data center integration, which I'll be talking about a little bit later, HA clustering, and lately the server virtualization, which is integrating the KVM port into our appliances. So we can deliver converged storage and virtualization on the same appliance. And this is just an overview of what the technologies are. So at the beginning, we, of course, focused on delivering to the customers appliances that were geared towards backup related activities. And we took advantage of the really nice feature of ZFS send receive. And this is very important and was and still is very important because of the way it decides which are the differences between the file systems. So this is a huge advantage against traditional rsync, for example, or backups which every time they need to get the differences, they will have to traverse everything. The way ZFS is built allows this operation to be very, very fast, and compressing that over the line would shorten very much the amount of data and the amount of time required to transfer. And we've been using this successfully with customers, like they're implementing their own disaster recovery with their customers. So they take our solutions, and then they put some little systems at their sites, and they use send receive to back up off-site. So this is one of the solutions which is really interesting to our customers. And we're doing this in Italy, where the internet is very crappy. So this says a lot about the power of the technology underneath that allows us to do that. Okay, then another thing that we actually added recently was the integration of KVM. So right now you can, of course, on supported hardware, as our colleagues from Erastor said, we are going in a different direction in terms of hardware support. So we'd like to, and this is where we're moving with all of our partners, OEM partners. We work with them to define a really stable line of hardware that's really usable, because that's a good idea for them, because they don't have to run around, see if this works, what's the performance, what are the characteristics. So this is another type of value that we offer them. So we work with them to define lines of products, like they did and others are doing. And KVM is supported on certain hardware, and we are taking advantage of having KVM directly over ZFS, so that we can deploy very fast clones, something similar as Delphix does with the databases, but we're doing that with appliances or virtual machines that run directly on the appliance. So you have a template and you can instantly provision a lot of machines. So it doesn't matter what you're running inside, but you can deploy test scenarios, deploy virtual desktops, deploy them very fast. And then, given that we have the ZFS replication, we can also replicate the virtual machines and run them where they arrive, on the disaster recovery side. So the interesting thing is that on the other side, if it's also a Syneto appliance, you can also run the appliance if you have a total disaster on the side that you're sending. Then another important thing that we've been working on is the HA, and we've been doing a lot of work of integrating the Linux HA infrastructure, Heartbeat, and so on, and porting that to Solaris. We've been releasing the things open sourced on our GitHub repository, and well, the bits and pieces that we did for the porting. And of course, implementing all the wiring required to seamlessly manage import and export, so that all configuration which is related to the pool that gets moved across head nodes is kept together with the pool. So that's an important thing that we had to do, because this actually works with or without HA. So we kept not only the NFS shares and the iSCSI, or not iSCSI, the chips shares, but also the iSCSI configuration related to that pool. So for example, if we had a LAN which has been shared to some, or let accessible through one LAN, that configuration is also kept with the pool. So if we move that pool to another machine, this will get automatically reconfigured. Okay. Another another type of work we did was trying to integrate very well with the VMware infrastructure, because a lot of our customers are using VMware, and we developed some very interesting integration which was available, but the thing is that there hasn't been a storage appliance provider that started to do this work. And what is interesting is that the level of integration allows us to bypass one of the fundamental problems of VMware snapshots, is that they tend to rise in size over time. So unless you decide to consolidate them after some time, first the size of the snapshots will grow uncontrollably, and then the time to consolidate them will raise without control. So if you want to keep VMware snapshots for 30 days, for 60 days, you cannot just keep snapshotting on the VMware side and keep the snapshots there, because then consolidating would take so much time. So what we actually do, we control from the storage appliance, from the scheduler, because we have a scheduled snapshot mechanism, so that we can work together with VMware, so that we take a snapshot in VMware, which can be consistent memory-wise and disk-wise, because VMware has that capability. So we take a consistent snapshot of the virtual machine. If their database is running inside, it doesn't matter what is running inside. Everything is consistent. And then we take a snapshot, a ZFS snapshot, so that we can freeze that moment in time. And then we reconsolidate the virtual machine from VMware. So this means that the virtual machine from VMware never has any snapshots, but if the customer decides to restore something, it will restore the virtual machine live running at that time. And the core for that we also open sourced, and it's on GitHub, and it's just the infrastructure that we use to communicate with VMware and so on and so forth. And we did some other improvements like auto-expanded data stores. So if the storage appliance is integrated, you don't have to make 5 steps or to recalculate, re-expand, and so on VMware. So you just expand the ZFS data store, and then VMware will instantly see the space available, even if it's on iSCSI. We did some work with deploying virtual desktop infrastructure. This is something like it's generic, so you don't, but just to showcase a little bit of things that we did, we recently deployed a large VDI project at the University of Milan, and they were really impressed of the number of virtual machines that could be run instantly and auto-provision. We didn't use KVM, the internal KVM for that, but we used Red Hat's VDI deployment. Apparently, they had everything for free from Red Hat, so they just needed some very fast and reliable storage appliance to run those virtual machines on.
If I can interrupt, I was just curious how does deduplication work for you? Like, what kind of performance are you getting? What kind of hardware are you running on? And is it working well for you, or do you see problems there?
Yeah, with the duplication, we have problems in the sense that it's largely dependent on the block size. So if the block size gets too large, then you don't get that much of a benefit of using the DDAP. If the block size is too small, then we have to be very careful on the amount of memory that we install. But there's a sweet spot where DDAP works very well, and we've been experimenting lately with new algorithms from that SASO implemented with EDON-R, so that we, in case we hit CPU, well, the CPU becomes the bottleneck, then that's something that that really helps. We're not right now. We're thinking about including that that kind of work, because I think that it's gaining some advantage in certain situations.
Cool. What block size do you see as being working best in this situation?
Well, I think that well, our default block size is 32K. This is what we decided to use on by default on volumes, but DDAP is not. It doesn't have the best ratio on that kind of. So usually we have to tune it down. So I think that 8K works the best in terms of space gaining, but that there's a lot of problem with memory in that situation. So
yeah, that all makes sense with my experience as well.
yeah, that's it. Other, because that was quite about it. So I was this wraps it up. So these are the things that we put together, we test, and we are very attentive of how we develop software, because I think that's something that has been overlooked in the industry over time, so that we can how do you validate that that thing works, and if changes won't break anything. So we've been trying to be very agile in developing stuff, and this is a talk that my colleague Vadim will give afterwards, a technical talk. But in the meantime, you can ask me questions about our appliances and our stuff.
I have another question. Are you using the KVM that was ported to Lumos for SmartOS?
Yes.
Yeah, cool.
Yeah, but we're well, it's the engine, but we didn't use exactly what they did with the zones. There's a couple of differences. What we thought was a better idea was to make the system more transparent. For example, we're not using zvols to store virtual disks, but we're using QCOW2 or something like that we can export over NFS, for example. And we can. This is a very easy way to exchange and to make it flexible. For example, you can use the storage. If you don't want to run the hypervisor directly on the storage, you can run a separate hypervisor, and run the virtual machine from the storage. This is one. Or we can also import virtual machine by just renaming a couple of files. So that's, in terms of interoperability, we thought that that's a better idea.
Cool.
Thanks.
How do you handle the high availability in regards to the ZIL? Do you duplicate it with the RBD or some other technique?
Okay, so usually all the disks in our HA deployments are shared between the nodes. So what's behind, it's actually a SAS network. So actually the ZIL is actually visible by both nodes at the same time. So you don't need to replicate anything. That goes the same for the data disks. Well, there's a discussion with our friend here from DDR Drive that
Exactly.
if he will give us a good solution, that will be, I think that will be the happiest people on earth. Of synchronizing the two DDR drives, that would be awesome.